So we now want to look at an example of an inequality which involves the modulus sign. This example, I want to, again, there are different ways of solving and tackling and looking at such inequalities. This one I would like to look at purely graphically. So what we are going to do is we're going to look at each side of the inequality as a function and graph them, and then through analyzing those graphs we will write down the solution. So the right hand side will be easy, but the left hand side I'm going to first manipulate a bit. So 3x minus x squared over 2 factorizes into x times 3 minus x over 2. So if I look at this as a function in x, we see that it is a concave down parabola, right? Because I have the minus sign in front of the x squared, and the places where the parabola crosses the x-axis is at 0 here, and at x equals 6. See, somewhere here. So it's concave down. So it will be a parabola like this, but applying the modulus to this expression, we need to flip up the parts of the graph lying below the x-axis. So instead of coming up from here to 0, the graph will come down to 0 like this, curl up, and then go back up. So this is the graph of y equal modulus of 3x minus x squared over 2. Into the same picture we are going to graph y equal 2x. That's just a straight line through the origin, looking roughly like that. Right, so this is y equal 2x. Right, now solving this inequality here means, well, I ask myself for which x is this expression greater than or equal to this expression. In terms of the graph, that means for which x's does the graph of this function lie above this graph, right? And so if I analyze this here, as I see all over here, this graph lies above the blue line. At 0 they're actually the same, but that is allowed here. So we allow 0 will be a solution to this inequality. Then we expect there to be an intersection point, right, at which point the behavior changes. So all these axes up to whatever this intersection point is will be solutions, whereas these axes won't, because they are the blue graph is above the black graph. And then possibly somewhere out there the behavior might change again. We don't quite know yet, because my picture is not precise enough, but the algebra will reveal that. So possibly at some point the black graph will overtake the blue one, and then we'll get more solutions beyond that. So what is important here is to find the intersection points. There's definitely one here and possibly one over there. So let's first try and find this one. So what do we have to do? This graph here is part of the graph of this function. There the modulus symbol was irrelevant. To find the intersection point with y equals 2x, what we do, we'll just set the two terms equal to each other. So we are now looking for the intersection points. So we are setting 3x minus x squared over 2, coming from here, equal to 2x. And we solve this as a quadratic equation. So I'll put everything on the right hand side. I'll get x squared over 2. I get 2x minus 3x, it's a minus x. And this factorizes into x times x over 2 minus 1. And I see that this happens if x is equal to 0 or x is equal to 2. 0 is this intersection point, and we found out that this happens, so this intersection point happens at x equal 2. That's where the blue graph overtakes the black one. So that's this bit. Now we said possibly there's another intersection point over there. So how do we find that one? Well, for this part of the black graph, the modulus symbol was actually relevant, right? So it's not, this part of the graph doesn't come from this expression, but from its negative. So we need to take the negative, put a minus sign in front of this expression and set it equal to 2x. That will give us this intersection point if it exists. So we'll take the negative of this expression, which is minus 3x plus x squared over 2, and set it equal to 2x. Right, so again, I'll put everything on the left-hand side. It gives me a minus 5x. And this factorizes again into x over 2 minus 5. And that happens when x is equal to 0, just the old solution here, or when x is equal to 10. So indeed, there is an intersection point a little bit further over there, 10. Somewhere here, these two functions meet and the black graph overtakes the blue graph and will lie again above it and will therefore contribute. So the numbers beyond that will be included in the solution. So without any further algebra, we can now write down the solution. So let's just summarize. So we have that 3x minus x squared over 2, the modulus of that is greater than or equal to x over 2, if and only if, well, for which x is this the case, we already established that for all x is less than 2, anything here, the black graph lies above the blue one, we need to exclude the values between 2 and 10, and everything beyond 10 again solves the inequality. Okay, so that's the solution to this inequality.